Hello friends, welcome back to the channel. In today's video, I will discuss about resistance. So without delay, I will start our discussion. The resistance, it is a property of a material by which it opposes the flow of electricity through it. Or in general, we can define that resistance is a property of a material by which it opposes the flow of current, flow of charge, or flow of electricity. So if any material is having low resistance, it means that material is conductor. If any material is having high resistance, it means that is an insulator. And if any material is having resistance between low and high, then there is a third category of that substance, that is semiconductor. So that I am not going to discuss in this video. I will discuss about semiconductor in some other video. You need to stay connected with the channel for watching that video, and for that that you have to subscribe the channel, and after the subscribing, don't forget to press the bell icon. So let's move ahead. Insulators does not allow the flow of current because they are having high resistance. So insulator does not allow the flow of current. Now the resistance, actually the unit or the measurement of resistance can be done by unit, that is ohm. It is denoted like this. So if we can we have to say that the value of a resistance or a conductor is having resistance 1 ohm, then we can say only if that conductor allows 1 ampere of current if 1 volt voltage is applied across that conductor. In other words, uh, if any conductor is allowing 1 ampere current on application of 1 volt, it means that conductor is having resistance of 1 ohm. This resistance of a conducting material, that is directly proportional to length, inversely proportional to the area, directly proportional to the resistivity, and it also depends on temperature of conductor. So a general formula for resistance R is equal to rho L upon A. Rho is the resistivity, L is the length, A is the area, R is resistance measured in ohm, and it is denoted by this symbol in any electrical circuit. So resistor is a dissipative element. The it converts electrical energy into heat, and electrical energy into heat. If I current is flowing through R resistance for T time, then I square RT will be the heat production in that resistance R. And the law of governing the current and voltage, or we can say that the relation between voltage and current is V is equal to IR, or it is Ohm's law. I will discuss about Ohm's law in detail in some other video. Then resistor can be regarded as linear only within the specified limits. Outside that those limits, this resistor behaves as non-linear because it depends on temperature. Resistance depends on temperature, and dependency on temperature can be expressed by this formula. RT is equal to R naught 1 plus alpha T, where R naught is the resistance at 0 degree centigrade, RT is the resistance at T degree centigrade, and alpha is the temperature coefficient. It may be positive and negative both. In the upcoming video, I will discuss about the dependency of resistance on this alpha. Then T is the temperature in degree centigrade, and power dissipated by resistor is P is equal to V into I. If we are expressing in terms of voltage and current, and P is equal to I square R or V square R watt. This is the power dissipated, and this I square RT is the heat produced. So this is the brief introduction about resistance. Then if resistances are connected in series, so suppose this R1, this is R2, and this is R3. So this is terminal 1, this is terminal 2, and R1, R2, and R3 are connected in series. Then R equivalent will be R1 plus R2 plus R3, or if more resistances are connected, then it will be like this, plus plus R10, if circuit is in this way, that n resistances are connected in series. If resistances are connected in parallel, so suppose this is R1, this is R2, this is R1, this is R2, and we have to find the R equivalent. Then this R equivalent will be R1 into R2 upon R1 plus R2, or this R equivalent will be 1 upon 1 upon R1 plus 1 upon R2. And similar way, if n resistances are connected in parallel, so this will be Rn, then this will be like this plus 1 upon n. So this is all about resistance, and resistances connected in series and parallel. In the next video, I will discuss about the temperature coefficient of resistance, how it varies with temperature, what is positive temperature coefficient, what is negative temperature coefficient. So for that video, you have to be connected with the channel. For that, subscribe and don't forget to press the bell icon. If you want any particular video, then you can comment in the comment box. You can also share your views about video in comment box. Thanks for watching.